Hello, I accidentally just hit the stream button instead of the mic and mic. I don't need that button either. Oh man, I pressed all the wrong buttons. Um, uh, Sorry about that, everybody who was watching and then just had the stream shut off and then turn back on. Um, I think, however, Twitch will treat it as like a single stream still since it was like instantaneously back online. But that might have triggered some advertisements. So I'm so sorry. Just give like half a minute for those to run through. So my day is going great so far. Totally not pressing the wrong buttons. Staring at it going like, what's that button again? The one that's sitting there that I always hit to stream? I wonder if I should press that. No. The answer is no. Okay, so what are we doing today? Yesterday we left off with our CLI sort of like choice collector. With we have these arguments coming in, so we have like the options essentially, and by default we have interactive mode is true. So I think we want to go with that first. Now Twitch mode is going to be interesting once we get into that. But let's do interactive mode first, because I think what we're going to want to do is modularize these into different sort of sections, and that way, depending upon if it's Twitch mode or not, we'll be using one of these other modules. So here in our main library, we want to check to see if we're interactive mode, and if we are, probably we'll just create another mod in here for interactive mode. So basically we could make it fully self-reliant. Not sure. Let's create interactive mode. Now, do I need you to be a struct? Probably yes. Like no matter what, there's some shared interactivity, which is I'm collecting things for a certain amount of time and then shutting it off, which then writes it all out. So there's probably going to be a lot of like sort of shared libraries, like maybe like a helper file or utilities. I can definitely see that being true. But if we're going into interactive mode, do I need a struct for this? I don't know. We could have a struct even if it doesn't have any, we could have a struct even if we don't need any state in it. Like I could just do this. Which might make sense. It also might not. I don't know. Okay, so if we do this and we have like a run, actually let's even just go back. Let's just do like pub function run. So interactive mode run. What do we need to take in? We're gonna need to take in our main state, which is gonna be a mutable reference to the main state. And then we're gonna need, what else would we need here? And like trying to think about like what is the difference between interactive mode and Twitch mode, really, like truly behind the scenes. We're gonna be asking like where we're getting the choices from is not gonna be coming in through channels. unless I can do those somehow asynchronously. Let's see. In the standard library, if I want to sort of like read line, let's say from standard in. I could throw this into a thread, potentially. That might be really interesting. So let's say I throw this into a thread, and I have a channel for it to send these back on. What we care about the name and the color. Like that's all we really care about. So regardless, we're gonna want a struct. We're gonna want a struct for the actual choices. So do choice. So we're gonna have a name, which is a string, and then we're gonna have red, which is, I guess, just an F32, green, F32, blue, F32. And that's what we're gonna be putting out, is something that looks like this. We'll probably even be using this for assert serialize. Chantilly, hello. How are you doing? Which we can also import choice. Now, red, green, and blue actually are optional, aren't they? Because if I don't have a red, green, or blue on, then it just becomes like 0 for them. Or 255, like white. What did we do for that one? Now I need to go look again. Yeah, okay, so we can choose to have like red, green, and blue here. And so if we look at our choice, it chooses the default color if it doesn't find it. The default color being 0, black. Okay, so that's good to know. I guess this makes it a little bit interesting. Do I want to force to have a color on here? I don't know if I want to, which means these need to be options. Now name, we have to have name, but then these red, green, and blues can be options, which means, okay, so impl choice. Do I want to do like a build on this pattern? It's not, I don't know if we need like a builder for this. We could, it might be simple enough. Let's just try a standard constructor for it. So pub function new. We'll have the name, which is a string. We'll have red, which is an option 32. Okay, so then it just becomes ourself with name, red, green, and blue. So given that choice, if I'm going to use something like channels, then something like this interactive mode would run a channel, collect the choices from the command line, and then send those in a channel back to here. So those could create a new one. That creates a new choice. Okay. So regardless of the arguments and which like sort of path we take, we might want to store those here. Okay, so let we have like a sender, receiver, and if I remember correctly, we don't want to use normal channels. We want to use what is it called? Crossbeam channels. That's what it is. In this case, it's going to be unbounded because we don't know how many we're going to create, and I don't want to like preset memory in the case that like we'd have to say like 5,000 of them. All right, so if we create this, like we now have our sender and receiver of like how they're gonna work. We're gonna want a receiver stored here. So receiver is gonna be a crossbeam receiver with, I guess, a choice in it. So we're going to store this away. Now we can clone that sender to send to whoever we want. So for example, we give it to our interactive mode and it can store that away and then use that. That being said, which one do we care about? If I use a trait, I could basically choose whichever one is the one that we're going to be using and store that away in here. That might work. Like, let's say we have a, I don't know where to put this yet. So I don't even know what it's called necessarily. Maybe this could be like our mode, like the collection mode. And if I don't know what you are yet, that should be fine. But we're going to implement you for, so this is where we do need, for interactive mode, we do need to have this be an actual struct. I don't know what I'm storing inside. Let's just create a constructor for this. I've just keep on getting burned when I don't create them, so I just create them for everything. Okay, so I've got that. I guess you know what I could do is I could derive default, and then I don't need the new until it's necessary. So that way it's still like a function call that's happening. You go up there. Okay, so I have interactive mode. That. I want to now import. What do we call it? Collection mode. So collection mode for interactive mode. There's nothing to do here, so it's really just like a marker trade right now. But back in the main library, if I want to store this away, we can have our collection mode, or like a collector. We're gonna have to box this up, aren't we? So we're gonna have to box, and then dyn collection mode. So the way that works here is we'll just say let we can box it up at the very end, or it could just happen in here. So let collector equals if arguments dot interactive mode. So if you're true, then we're going to want to create the collector and like return it in a box. So we're going to do a box new. This is going to be interactive mode default. That gets returned. Oh, this is going to be interesting because collector has to be something. So I would have to do something like a panic or like a bail. No. Like there's no like no collector available. Is that because this collector and then we store it away? So we're doing a little bit of dynamic dispatch with this. But it now allows us to just shove whichever collection, like whichever collector mode we're going to be using. So interactive mode or Twitch mode or something else, like whatever unique logic for this can be stored in here. And then the shared stuff can be in main state. And that way we can like we can pass whatever main state we need in, and so on and so forth. Okay, so what's the first thing that we need to do here? We need to potentially give it its sender, so it can send like back on the channel. Might be really helpful there. I guess like what's the first thing? Like we're gonna have like a run for it, aren't we? So all the methods we're gonna call on this actually have to be defined in our trait here. So if we have like a run, this is going to be a self, and we're going to pass it in a cross beam, a sender. That takes a choice in. And I think you need to return a result. So something like that. Okay, so we have this function run. Take this. Well, that's different. You turn it into an underscore. Okay, that's cool. All right, so what are you? You're the sender. We need to pull, have you in. This is a channel. How are you okay? How did you get that out of here? That's weird. And you are a choice. Now, so I could just like right away send the choice, but like when we're running, the first thing that we want to do here is probably print out. So we're gonna print line collecting choices interactively. So if I just do that, and then we're gonna have to return an OK. And okay, so we're happy with this. Then in the my library, we're gonna have a run function. So function run. Let's go ahead and just return this as result2. And do self.collector.run. We have to pass it in the sender, which means we need to store this away too. And then you're going to be a self.sender. And I'm returning this because it returns the same result. Cannot move out of self.sender, which is behind immutable reference. I believe I can just clone this. Yeah, we can just clone it. Okay, so perfect. So if we run you now, oh wait, we can't run you yet because run is not being run. So then in main, don't need a debug main. Well, debugging that might be helpful. Although we know that it's correct now, so I probably don't actually need that. What we're gonna want to do is say main state dot run. You need to be mutable. Okay, no errors, just a bunch of warnings. But if we run you, okay, so we get that collecting choices interactively. So perfect. So now we can start like actually building up and you know, requesting from standard in. So if we come back to here, how does this work? So read line locks this handle and reads a line of input, appending it to the specified buffer. So how are we going to have like a choice and then choose what the color is going to be? I almost feel like for this, we're going to want to like grab red, green, and blue separately. So like we're creating the choice, now they're going to set the name. So, okay, let's just say right away we ask for, we're going to ask for the name. Okay, so collecting choices interactively. Print line. What we can do is we just do print name. By doing print like that, I think what's going to happen is it's going to be on the same line that we're going to request the line on. See, here's name. And then I want to read line. So we're going to do IO standard in read line, get the in pass. Okay, pass it a reference to input, and then that returns a result. So we'll have a let mute input. Okay, that's a new string. Standard IO. Oh, I need read in here. That's my problem. Okay. Also, I need this self. Wait, it's this one. No, I just need that. I don't need anything else. Oh, standard in is a function. Oh. So wait a sec. Standard IO, standard in. Okay, so standard IO, standard in. Then we got readline. And it a mutable reference to input. It's going to throw that into there. I'm going to question mark U for the result. And then we can just debug this out. So debug our input. I'm really sad about this. Collecting choices interactively, I was kind of expecting that print name to happen before this happened. So if I go like test, name happens after that. Is it threaded? Oh, that's too bad. Okay, so I think what then we want to do is use print line, name. If I do that, yeah, name. Okay, so name, this would be like choice one. So then we have this choice one there. Then I do need to trim it. So we're gonna trim you. That will remove the RN off the end. There we go. So then we just get our test, and then that's going to be added to our choice. So now that I think about this, when I create a new, I don't want to have to pull in the color information. I think I would want to just like pull in the name, but then the rest of these are just going to be nuns. That being said, I would want to, okay, so grab our color off here. So I don't need you. We're going to do let mute our choice. We're going to start building that. It's going to be a choice, new, and we pass it in input. That gives us that. Now, let's say I want to do color. Now we have a U8 for that, but we couldn't change. We can change this. Like the output needs to be U8 at the very end of the day, but that's not really that big of a deal because we can like play around with it. If I want to do RGB, there's lots of like choices. Let's say I open up the dev tools. There's this like dropper tool. Yeah, this gives me like that sort of like hash of RGB. So let's choose like, I don't know, this purple. So once I get this, I want to get the color. So that, I wonder if I can use the input again for this, or if it's gonna append to it or overwrite it. I don't know. Let's find out. So let's let color equals. Actually, we have to redo again, which means we have to do another print line. Color. And we do that, and then I want to debug input. All right, let's find out what happens. Oh, right. Okay. So we give input to here. So we can clone you. But we're probably going to want to function this so that way it's like new every single time and it returns what the choice is. That makes the most sense to me, especially since we're repeating this over and over again. Pollux, hello. How are you doing today? So if we run you, name, we just say like choice one, color, we'll throw, okay. Choice one, yeah, so it just adds on to the end. That's what happens. Huh, it even added in a tab character, which is interesting. Oh, you're doing great. That's awesome to hear. All right, so let's create a function in here. So we're gonna have a function. It's not gonna be you. It's gonna be up here. We're gonna have a function. This is gonna be just like, I guess, read line. I don't know if I guess we can we could have like what we're reading in too. So this could be like the description, which is a stir. And then we're gonna just return a string. So we're gonna return a result with a string inside. So then in here, we're gonna have a print line. Then that description. Then we're gonna create a new string. So let input then we're going to standard O, standard in, read line with reference to that input, question mark U, and then we're going to return the trimmed input. So input dot trim. Yeah, returns a string slice. Oh, okay, so that returned. Then I think we need to clone you to make sure it's actually a string, we don't lose it. Otherwise, it's going to be, there's going to be a problem. Okay, so then we can read line here. And I don't need any of you anymore. So what's going to happen, we don't even need to do this. We're going to say let name equals self dot read line name. That gives us that. We can even do like let color equals self dot read line color. And then let's debug name and color. Also, let me recopy this. So there's this interesting color. Oh, expected enum results. I need to okay this. Wait, can we not do trim? We have to do trim on a string, right? No, because that's a stir. Okay, that's a result with a string inside. So input is a string. Wait a second. What's going on? Oh, because trim. Wait a second. Okay, so trim, hold on. Trim returns. Okay, can I do like two owned? That's what I need to do. Okay. Back to copying this again. Okay, so name, we're gonna do choice one. Color, paste you in. All right, so it's awesome. We're able to grab the choice out and the color out. Now this is an RGB format, but like hex formats, we need to convert the hex to like either that or we're gonna have to ask for like red, green, and blue. But I think it's gonna be a lot easier if we like just choose colors. This could even be an argument here of like what type of color we're gonna be using. Like RGB like this, ask for red, green, blue. I kind of like this because it's like all of the droppers that I ever use just return in this format. So if we do that, let's go find a crate to convert this. I just want something to convert colors. I suppose. Is that CSS color actually usable for this, or is it only... Aha, okay, so we can convert. So we have that. It's not necessarily helpful. I want to convert from the other method where I have like the hash and then three colors together, which is sort of this, but not really. Do you have documentation showing? Yeah, I don't think this is what I want. Okay, there's 2 CSS, 2 RGB, 2 RGBA. Let's see. Is there like from? No, there's no from. Okay, so I don't think it's this. What is it that I need? I need... It's like the RGB hex to... Maybe something like this. It's been used like... Ooh, okay, maybe this one. This has been used a little bit more. Here we go. Okay, so we can have our let hex equals this, which is what we want. And then we can do hex to RGB. Okay. And then back again. So I think we can use this. So we have to create it, we have to turn it into an what is it? HS love. And then we can turn it into a RGB. That's what it sounds like. We have to turn from hex to HP love, and then from HP love to RGB. But I think this will work. So let's go ahead and bring it in. So this is Rust HS love. Okay, so given this color, let's say we want to do the, we're probably gonna want to do this in a function, aren't we? Because what if we don't have a color? Like what if I run this and I just say like choice 1 and I just don't give a color? Yeah, it's gonna be an empty string. So what I'm thinking we want to do is convert this into a function, convert this into a color here. So This is going to be like string to color. Convert string to color. We're gonna have the string come in, so that's gonna be the string color, the string. And then after that, I don't think we need to return anything. Okay. Well, we don't need the second thing coming in. We're gonna have our. I'm just gonna call this the string. Then we're going to return an option. Do you return a result? Doesn't look like it. Looks like we could just do it. So an option with a... Is this still going to be a string? It's going to be something. Looks like it's gonna be a triplet. So F32, 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 like that. Which I suppose makes sense. Between 0 and 1. This doesn't seem right. Unless that's like Q or something like that. Not what I'm expecting. All right. Options. Then, okay, so first of all, if our string is equal to just like has a length of, okay, we can just check this. Is empty? Okay. So if string is empty, then we want to return a none. If we get to this point, let's now go ahead and convert this string over to this thing. So it's gonna be hslove RGB to this and pass it in this thing. Hex 2, okay. So let, don't know what that is. hslove hex to HS. Oh, we can just do hex to RGB. Maybe that will be better. So then so you want to stir. So can I just do a reference to the string? In which case, can we grab you out? Let's just return a none here. And I want to debug the result. Okay. Then down here we have our color. I want to then self dot convert string to color and then pass it in the color. And I want to debug you. All right, run this again. So we have name, start trace 1, color. So if I do something like FF0000, okay, this gives me 1, 0, and 0. Now previously I was looking at this from like a 255, like a U8. If I were to do this, I would need to use like some kind of mapping function to convert a number to like then blow it up. However, I think this could be just as fine. And we could, in the actual other choices, we can just switch this around. It's pretty easy for us to, in here, say, you know what, you need to be like 1.0, 0.0, 1.0, and go that way. So I'm okay with like leaving these as this. Josh Finney, hello. Color sys looks like it might be better. Let's go take a look at the color sys. Color sys. Okay, this might be better. Yeah, let's try this. Well, because, okay, it can be U8s. Nice. Okay, perfect. So this is color sys. Wrong project. All right, so interactive mode. How does this work? So we can do, oh, they use structs. So RGB from whatever I pass it. So I wonder if I can just do RGB from hex string. Yeah, okay. Right here, yeah. I might need to remove that hash in front of it, but that's not really that big of a deal. Okay, so here, convert to string. Okay, so we're gonna change this out. This is now gonna be a color sys RGB from RGB from hexster, and let's pull in a reference to the string. Question mark U. There's that RGB, and then we'll just debug that result and sort of see what we get. Wait a second. What do you you return a? Oh, you return a result. Okay, let's return result. It's an okay. The none. Also an okay. None. And you're gonna have to be question marked here. All right, let's try this again. So if we do name choice 1, color is, let's try it with the hash. So we do FF0000. Aha, here we go. Okay, we get 255,000. So that is perfect. So if we do this again, I believe I can now convert that to a U8, no problem. Can I tell it to convert to U8? Oh, into, I think that I can. So if I say each of you be U8, so hex string result, we're going to do an okay result dot into. It's not satisfied. Okay, so RGB from You don't know what to do. Okay. Oh, I was hoping that would work, but don't think it knows how to do an into for that specific thing from here. So this is probably gonna have to remain as, let's see, these are RGBs. What else do we have on RGB? Result dot. There's that into. Yeah, that's not really super helpful. We take a look at their documentation. Okay, we want RGB. Okay, so we have the from hex string. It gives us that. 2x string. We can get, okay, the red, green, blue. Oh, they're F64s. Okay, so they're into, they have an into for F32s. That's why it works. I16s, I32s, U16s, U30. Oh, here it is. Into U8. Oh, it's an array. Oh, here it is. Look at this. They have an into for a tuple. They have an into for a tuple. Okay, so why don't you work? Okay, because you need to be an okay sum result dot into. And if I just do this, even without the into, would you work? Mismatch type and that. How about then a dot into? There we go. Okay. Then we're going to debug the convert string to color. So name. Then if we do like hash f 00 12 255 0 18. Perfect. Okay. So that gives us our color. We now have like a tuple of the red, green, blue in here. So now we can actually create our choice. Thank you so much for that, Josh Finney. This is an awesome crate to use. I like that a lot more than this other one. All right, so we have this create the color string. Convert the string to color. So what does that mean? We can shadow the color, or we could just call this the color string. Let the actual color is equal to self dot convert string to color string. That gives us this option, meaning we're not sure what we have. We can then create, so let mute, choice is a choice, new, pass it in the name. Now, this gives us back a owned choice. So if I want to do something like with with color, then we can pass it in this. Or we have this option here. Let's just come in here. Let's add this in. Then we have the color, which is an option that holds U8, U8, U8. We can then grab this out. If let, let me do let red, none. Okay, so if I create those ahead of time, now I want to it's if let some get the color, so this is being red. Guess we'll just like RGB equals color. Then we can do red R, green equals G, blue equals B. And then those get stored away. Oh, of course, you're gonna have to be sum for this. Oh, and you need to be you need to be U8s. What am I thinking? You're U8s. And you need to be sum. Okay. Back to you. So new, and then we also pass it in this color. Now we can debug the choice. You don't need to be mutable at all. Choice does not implement debug. Let's fix that. All right, let's try this again. Name is gonna be Choice1. Color is, let's just choose a nice color here. Let's get this nice blue. There we go. Okay, so we got our misspelled choice. We got a red, green, and blue, which is there. Okay, perfect. Now we know that the default is black. So would it make more sense for us to, instead of having these be options in here, what if we were to have you just be U8s? Like that. Red, green, and blue become, instead of this none, you become zeros. Then we don't need this entire sum. That way, if we have a color passed in, we're gonna set them to be whatever is passed in. Otherwise, we're gonna stay with our defaults, which is, well, black. And that makes a little bit more sense here. Okay, then that can be stored away. And if we look at the way this works, yeah, it's gonna be the name, red, green, and blue potentially added here for each of these. So perfect. Okay, so once we have this, I want to then send this choice away. I'm gonna do sender dot send. The message is just gonna be the choice. Which means we need to loop this for as many times as exists. Otherwise, like, this is just done. Because if I just send and we're done, I think we can't actually get this, can we? Do we have our receiver? Okay, so let's see. Let's try it once. So we're gonna do a let the choice equal to self dot receiver dot. Let's just try a recv question mark. That gives us a choice. And we're going to debug that choice. Then up here, do we have any other debugs? No, no other debugs exist. So this is gonna let us know whether or not this works. We have a choice one. We have like F, BB, AA. There we go. Okay, so in the main library, we're able to grab this out. So what that tells me is we could do this as many times, like collect them all. It just builds up inside of that, inside of our channel. So like as many as we want, and then we process them here. So let's now loop through this. So we don't want to just read. Okay, so collecting choices interactively. Also just do like another line here. We're gonna loop forever. And do all of these every single time. So like choice, and just like keep on grabbing the name and color. Now, if we don't have a name, so if name is empty, then it's time for us to break. So if I do this, it should allow us to collect many, many, many names. So first, second, third, and you're like a, that's great that we can pass it an empty string and it gives us zeros. So that's really nice. So then in our main library, we want to loop through all these choices to collect all the choices together. So then we're going to have choices. It's going to be a vec of a choice. I want to, once we run whichever collector we're running, we want to then loop infinitely. Receiver can't implement. Can I do an iter? I can do an iter, a blocking iterator over messages in the channel. Ooh, okay, so try iterator, a non-blocking iterator over messages in the channel. Each call to next returns a message if there is one ready to be received. The iterator never blocks. Waiting for the next, okay. So try iterator. We can then just do a for each. Probably need to do a try for each. This is going to give us a choice. Then we want to do a self dot choices, push in the choice. We can question mark you. I guess this doesn't need to be a try for each, does it? And then we're going to do a self dot choices, debug that. Okay, what do you get? Closure requires unique access to self, but is already borrowed. It'd be nice if we can do the choices push here, but yeah, we've borrowed it here for this receiver. We could create our collection here. Actually, now that I think about it, do we really need the choices up here? I don't think we do. I think we could create them here. Let mute choices equals an empty vector. And we're just going to push that in here and debug you. So you'll be happy again. We don't need you. So if I run this, now we should be able to get multiple of them. So like first, let's do like A, B, B, C, C. Second, you could have no color. Third, you can have like one of these colors. And there we go. Okay, so here are them all as we loop through them. So we have the choices, first, second, and third, and then with their respective colors added in. Oh, it's so nice. So then I want to save this out when we're done. So how is that going to work? Probably some kind of like function in the main library here. We can like write to disk. Let's have like a function save to disk. We're gonna take in the choices, which is a all the choices. So it's a vec choice. Probably gonna have to return a result. And then here's where I think Serde comes in handy. We want to write to a JSON and write that to disk. And I think Serde gives us that for relatively cheaply. Especially since this is such a simple struct. So we have Serde JSON. Yeah, we can make it to a writer too. Okay, so we need the derive. I think there's like a Serde derive we need too. Yeah, okay, this is what we need. Serde, add you in. Okay, that gives us that. For choice, we're gonna want to bring in serialize and deserialize for this, or at least serialize. I don't think we ever need to deserialize. So serialize. Use Serde. Serialize. Okay, that should make you. You're not unhappy yet. Then in save to disk, we want to take these. Okay, so toString. So we can do like a toString on that. So we can do Serde. We need to pull in Serde JSON, don't we? Yeah, we need to pull in Serde JSON. Okay, so then we can do Serde JSON. You can do like toString, toVec. Let's try, okay, toString, and then value is going to be our choices. Let's just see what it does with this. What do you return? Return a result with a string. So that, let, so like output JSON equals that, and we'll debug the JSON. We don't need to debug the choices anymore, but now at the bottom of this, we're gonna run save to disk and pass it in those choices. You're gonna be unhappy. Okay, so choices, expected a reference. Okay. It's not unhappy. So if you run you do one, just two, let's say. First and A, B, B, C, C, and then second, just nothing. All right, here we go. We have an array with name first, red, green, blue. So that's exactly what we wanted. So we now have this string to print, to like write out. And if I want to actually write this to disk, there is a standard IO write. Okay, so we can file create. Which that's what we're going to be doing is file create. And then we can just buffer write like the bytes. Right, some prefix of the byte string, not necessarily all of it. That's not what I want. Write all, okay. Write all might be what I want. Okay, so we need to create our buffer. So we need our we need the arguments, which is a reference to arguments. So then we're going to create the buffer. Let mute buffer is equal to the file create. Now the path. This is going to be arguments dot output file. That gives us that file. Then we're going to just do a buffer write all. And we have this. So buffer write all. And then I want, what do we do this? It's like a convert to bytes, but I think we can do this with JSON bytes. We can just give it into bytes. Yeah, it needs ownership of it, so into bytes, question mark u. So if I run u, okay, what are you upset about? Expected found destruct. Oh, okay. I think there's a vector of bytes. Oh, write all vectored is experimental. Oh, that's no fun. Can I do this to not have to use? That would be interesting. Actually, you know what? I don't need to write all, do I? Because this is just a string now. This is just a write now. Expected a reference of U8 found as bytes. There we go. Okay, then what are you upset about? Expected 2 arguments. So a reference to arguments. A reference to self.arguments. Cannot move. I don't need to, maybe. Now what are you upset about? Written amount is not handled. Use write all instead. Okay, or we have to do this thing. Because this is... Can we do write all? We can, okay. So write all. No error. So let's go ahead and try this. We're gonna cargo run. Name first. We'll do A, B, B, C, C. Second, with no color, and that's it. And here's our choices JSON. And out it is. It's a array of these. If we come back and look at the other project, it's an array that looks exactly the same. It's just formatted differently. And that's the only real choice here. The only real difference. If I format it looks exactly the same now. So perfect, we got the first section done. We're able to collect using standard in, asking interactively. So if I only have like, you know, I don't know, like 3, 4, 5, 10 of these to do, like I'm choosing what the next project is going to be and I don't want like too many, like one of each category, then this might be like a great way to sort of like do that and like set that up. So this is great. I'm super happy I was able to get this. That's not anything I need to care about, is it? No, it's not. All right, so what I'm gonna go ahead and do is stop the YouTube video here. So thank you so much for watching, and I'll see you next time.